Welcome back everyone to the Hello World Guide. This is another episode of the Raycaster game in C++ series, and in this video we are going to continue by well, I originally wanted to implement like textures in this video, but first of all I thought about doing some other things, and the first thing is that we'll learn how to actually load a map from a file instead of just putting it in there directly. And the way we'll load it from the file is that we'll start simple and basically load our map from like image. So like we'll have an image that will represent a top-down view of the map, and each pixel of the image will represent what color it is. And if that pixel is for example black, so we'll just assume that all black pixels means that there is no wall, while any other color means that there is supposed to be a wall there of that specific color. So implementing that is going to be not actually too difficult. It's going to be pretty simple. So I'm going to open up my terminal and go into our project directory, and in here let's begin by opening up map.h here. So map.h, I'm going to open this up, and inside of this currently we have got a vector of int, and we have got these two constructors. We are going to add a new constructor here that will take a cell size along with a string which will represent the file name, and let's make this a const reference too, and we'll need to include the string header. So this will mean that we are essentially using a file name to include this. So we've got like a file name, and we'll load our actual map from that file, and we won't be just doing it from any from a hard-coded grid. And after that, another thing we'll need to change is that instead of using integers for actually storing the values, we'll store them as an actual color. So for that we'll have include the color here, and we'll change this everywhere to sf color, and that's pretty awesome. So now another thing we'll change is that we'll remove this constructor, because we're not going to have any hard-coded grid here. So let's open up map.cpp here. Now inside of here, let's first of all go down here and let's create a constructor map, which will be our file name constructor, and it will take a file name, and we are gonna initialize our cell size to whatever the default value is, and for the actual like loading we'll use an SF image. The reason we are not using a texture here is because we are not drawing this image, we just want to access its data. So we'll take the image and load it, and we'll need to make sure we include the image.hpp header as well. You can see I'm doing that up here. So now we'll go here and say image.load from file, and we'll pass it our file name. So this will load that image from the file, and if it does not work, which means it returns which means it returns false, then we are going to check for that. And if it does return false, we are going to put an error saying fail to load map image, and we are going to return from this constructor. Now if that does work, the thing we will do is that we will go here and we'll set our grid to be an std vector, and we are going to initialize it with a constructor of well, this won't be a vector, or we're not going to pass in 0 here, but instead we are going to pass in sf color black. I'm going to remove that other constructor, by the way, and we are going to do it similarly for the default constructor that takes a width and height, and for this one we'll do it as well. So we'll take this essentially, and we'll take this color, and we'll just initialize our whole grid with that particular color. After we have done that, we can run a for loop. So we can run a for size underscore t. We are going to say y is equal to 0, and remember we are passing the image.getSize.y for the actual height, and we are going to say x for the width, and we are going to do it first height and then width. We are going to make sure to do it that way. We are going to go until we image.getSize.y, and in here we are going to just say y plus plus. And that's pretty awesome, but we're going to have another for loop here, which is going to basically be similar, but it will have x is equal to 0, x is less than image.getSize.x, and it will increment x like that. And now we'll say grid y x is equal to we'll take our image. So we'll say image.getPixel. This is a built-in method inside of image which will allow us to get the pixel. We'll pass it in our x, and we'll pass in our y like that, and this will get the image pixel and set our grid to that pixel correctly. And if I go ahead and open up my main.cpp now, we are going to change this so that we don't actually have this grid here anymore, and we are also going to go ahead and remove this constructor, and instead we are going to pass in a file name of map.png. So if I open up my this tree here, you can see we have got a map.png here. Of course we can't preview it here, but we have got that image, and it contains a bunch of a whole map with different colors. So like it does not like have one color, it have different colors, and we are going to render our 3D scene with different colors as well. So now the final thing we'll need to change is our render.cpp, because currently the way we are doing it won't work. First things first, we'll have to change this here. When we are actually getting it, we are not getting an integer here, so we can't use it this way. And by the way, another thing you want to make sure is that when we are using the getGrid function, we also provide it correctly. And another thing is that when we are drawing the map, we have not actually finalized this code yet. So first let's do that. We won't do any of this checking. If it is this, we'll set it to that. No, we won't do any of that. We are going to go here, and we are going to basically set the fill color to whatever the actual grid value is, and that's all we need to do. So we'll go here, we'll say grid y and x here, like that. So that is pretty awesome. We'll set our fill color to that, and when we are getting the grid, we need to make sure that the function signature here is correct. The return type is sf::color. So yeah, that's awesome. With that, we have got our map file completely implemented. Let's close that. Main is also done, so let's close that as well. And now rendered is left. So in here we get our grid, but we won't just check if we want to check it like this, because it's now not an integer. We'll just first of all include color up here, and then we'll check if this is not equal to black. So if our grid is not equal to black color, because since black can't have any shading applied to it, we are going to choose that for the empty color. And if this is equal to black, then we'll assume that we don't hit anything, and if it is not equal to black, then we'll assume that there is a wall here, and we'll do it like that. And on the horizontal checking, we'll do this similarly. So yeah, that's awesome. But now if I go up here, I'm going to remove the hard coded color value we have got here, and we'll need to get the map.getGrid, and we can pass it the actual coordinates of the map. But the problem is our array structure currently does not provide us with those coordinates. To do that, we'll need to have a vector to I, which means an integer. Actually change it to vector to u, unsigned integer, and this does not contain float, it contains of unsigned integers, and this is called our map position. Now down here we'll create two sf:: vector u. So we'll create an sf:: vector to u, and it will have two of these. One is going to be the vertical map position, and another is going to be the horizontal one. Now whenever we hit anything, we are going to set our vertical map position to vector to u, and we are going to pass it on map x and map y. And similarly for the horizontal one, we'll do it similarly here, but this time we'll set our horizontal map position. Now when we are returning our array, we'll do a similar check for this, and we'll return the smaller position depending on which one it is. So that should get that done correctly, and inside of here we can just access the correct index by using ray.mapposition.y and ray.mapposition.x. Afterward, this will provide us with our color, and let's go ahead and actually test that out, and it should work basically. So yeah, you can see that this is you can check out the actual map file. By the way, you can find it there, and you can see that it is causing a different colored walls, but there are two obvious problems. One is that the walls that are far away are kind of not being visible. The reason for that is that well, if I go up here, we have got a max raycast depth of 16, which is actually pretty low. So we'll have to make sure to change this to something higher. Let's set it to 32 or 64, for example. So if I set this to 64, then you should be able to see that that wall clipping problem we were seeing, we are not seeing it anymore, and it's working. But the main problem is that currently there is no shading. It's just flat color, and that does not look very appealing. So adding shading is going to be pretty simple. So unfortunately, the SF color class does not provide a method to just multiply the color directly. So we'll need to take this value. We can't just multiply this by shade. We'll have to take this value separately and store it in a separate variable. Let's call it color, and in here we'll need to construct another color, and we'll pass our color.r multiplied by shade, color.g multiplied by shade, and color.b multiplied by shade. So we'll need to pass all of that. After we have done that, it should actually provide the shading correctly. So yeah, now you can see that our shading is being applied correctly, and we are getting a pretty much working 3D map here, and it's going to be exactly like whatever you have made in your picture. So you can change your image dynamically and see the changes reflected here. So that means that our system is pretty much working. So yeah guys, this is pretty much it for this video, and in this one we actually created one of the more important things, which allows us to create a map while actually seeing it visually as well, and kind of makes our lives a lot easier. So this is going to be pretty awesome. So I'll see you in the next one, in which we'll add more stuff. Stay tuned for that. Make sure to like and subscribe as well, and share this video with other people. And